Okay, well, thanks so much for inviting me this afternoon to give everybody a tour around the moon because we're right in the middle of the 50th anniversary of the Apollo missions, and of course tomorrow is the 50th anniversary of the launch of Apollo 14 after Apollo 13 had the accident earlier last year, 50 years ago. So it's quite timely that we talk about the moon. And I've looked at the moon as one of those things that every time it comes around, it spoils your deep sky observing and comets, and that's what I'm principally interested in. But over the past few years, I've warmed a bit more to the moon, and I've started to enjoy it far more than I have over a good number of years. So it's a good time to show people some of the features that I've started to enjoy as I've got into it. Of course, the news is full of the red moon, blood moon, etc., so which drives us absolutely mad. But if you can catch the moon as it's rising or setting, it does produce absolutely lovely colours. And if the atmosphere is right, it goes all strange shapes as well. So that's something that's quite nice to look out for. And this was where it was just below Jupiter. So this was Jupiter some months ago as it was rising. So that was quite a nice catch there. And of course, when it appears in the evening sky or is disappearing in the morning sky, is how thin a crescent can you spot? So that's always a challenge to see how thin you can catch the moon. I've seen it a lot thinner than this from the UK, but this one was cheating. This was taken from the Seychelles. And of course, the angle of the ecliptic is much higher up than it is from the UK, so you do stand a chance of seeing it from more southerly latitudes towards the equator. So try and catch the moon as a really thin crescent as soon as you can after new moon or just before it disappears to new moon. And then of course catch it close to celestial objects as well. So when the moon's close to some bright planets or some bright stars or clusters, that's really nice as well. So here's the moon taken last year. So you've got Venus down here, and that's Mercury as well. I had to go away from home to capture this because I don't have a very good southern or western horizon. So I had to get out to try and capture these. So catch the moon when it's close to these celestial objects because it makes a really nice view. And then of course the earth shine. When it's a nice crescent, look out for the earth shine. And if you can, try and observe the moon then as well, because you can see one of the bright craters here, Aristarchus, is really bright, and it really does stand out when the moon's a crescent and it's got the earth shine shining on it because it is so bright. But we'll come to that in a little while because that's one of my favourite craters. And then catch a mineral moon. So if you take a picture of the moon, now you don't realise that you've probably got pictures on your hard disk or on your disk on your camera that you've taken of the moon that do show the colours of the regolith. So you can capture that quite nicely, and you've probably already got pictures that have captured that and not realised it. So I have put on my website a guide to actually producing a mineral moon using Photoshop by increasing the saturation. So give it a go. Get some of your old images of the moon out and see if you can draw out some of the colours of the regolith on the surface, because it's absolutely wonderful, because the bluer areas are rich in titanium and the brown areas are rich in iron. So you can see the differences on the surface, which is fantastic. And another huge feature is Mare Imbrium. Absolutely fantastic impact feature, and it's got so many little details going around it that you can spend just hours just looking at those. And then towards the southern part of the moon, we've got this crater here, which is Clavius, and it's just jam-packed full of these tiny little craterlets. And of course, it depends when you go out and what the scene is like, how small the craterlets you can see on the floor of that crater. But when you get a really good night, you can count lots and lots of craters. So get out there and keep looking, because it does change night to night. And this was a night that was really good, but the image is a little bit grainy. But you can see it's captured really tiny craters in the bottom of the crater. And then when the sun is just rising, these two craters in the bottom of the floor, because the edges of the crater are slightly raised above the rest of the surface. They just catch the sunlight as it goes through and creates this impression of the eyes of Clavius. So that's quite nice if you catch that at just the right time. And then we've got the straight wall, Rupus Rector. So here it is. So this is sunrise. So just the sun rising over it, and you can see it's creating the shadow. It's not quite as steep as it would look there, so it's not really a wall, it's more of a slight incline, but those long shadows do make it stand up really, really well. And you see this little rill down here near the crater Burt as well, which is quite nice. And then once the sun's actually gone the other side, so once you've gone past full moon, the sun is coming from the other direction, so instead of getting the shadow, you get it as a bright line in there. And some people have said it looks like a sword, a saber, on the surface of the moon, so that's quite nice. And of course the lunar X, everybody gets really excited about a lunar X. It's another one of these clair obscure effects that you can see, and Mary McIntyre produces a blog where she puts down the lunar X times. So here's the moon. So this was taken, it's just around first quarter when you get the sunlight just hitting it right, and you can see the lunar X just here, down there it is. And it just happens, it lasts for about 2 hours as the sun's rising over 3 craters, and it's Purbach, Le Carre and Blanquinus, and it's the ramparts of those 3 craters that just catch the sunlight and produce this X effect. So really, really nice to catch that at just the right time, but it only lasts for about 2 hours, and you have to see it at just the right time, because if the time happens when the sunlight hits it and it's below the horizon, you're not going to see it, so you can't catch that every single month. So there's the lunar X, but if you look at it a few days later, I specifically went out to take this picture just to show what the difference is. So here's the X a few days later when the sun is almost overhead on the feature, and you can see it doesn't really stand out at all. So nobody's looking at the lunar X at this time, so it gets a bit left out when it comes to that time of the moon. And if you leave it a little while later when the sun's setting, again you can see it looks nothing like the lunar X here, but the shadows are nice in the crater there, which looks really nice. The shadows look fantastic on the moon when you catch them bright. And of course there's the lunar V as well, which happens about the same time. Oops, I've missed my moon. There it is. So it's the lunar V here. So it's a little bit further north. So there's the lunar X, you can see there, and there's the lunar V. So here it is. It's part of Mare Vaporum, close to Rima Hyginus. So this is the Rima here. And then a few craters, Trisneca, Agrippa. I always think that sounds like a wrestler myself. And a few other craters around there as well. And Robin mentioned Mare Orientale, and here it is. So this is a view taken from Luke Jerram's Museum of the Moon, and if you haven't seen the Museum of the Moon, when we're allowed to, just go out and see it, because it's absolutely amazing. So this is a view we can't get of this huge impact feature on the surface of the moon, because it's just tucked around the edge, so we can't quite see it around the edge. But because the moon wobbles slightly, so this is the sort of view we normally get. So you can just see hints of it here. You can see this long bit here is this bit here, and this little wiggly bit here is the same as this one. And this is Grimaldi, one of the featureless craters, which is a little bit further around the edge. But libration, the moon wobbling slightly, this effect of libration, actually brings it more into view at certain times of the month. And so you can see here, this was taken on a different evening. You can see how much further Mare Orientale has moved into view. So we can see a little bit further into the crater. And sometimes it's not as good, sometimes it's not as far. So you have to wait for your moment to actually catch it when it's really leaning in. And here's an explanation. When somebody says to you, why do you keep taking the same part of the moon? Because next time you go out, you get a much better image because the seeing's much better. And so you can see this one was liberated in quite a long way, and the actual image came out really, really nicely. But it does need a favourable liberation to be able to see it. And here's one that was a little bit better that particular evening. You can even see the floor of the Mare itself just coming into view as it nodded into view. So yeah, we got a nice peek into that around the edge, and that was taken last year. The crater Plato in the northern part of Mare Imbrium. It's got these lovely shadows as well, and it looks pretty flat most of the time. But if you get the shadows right and you get the seeing right, get out with your telescope and see if you can spot some of these little craterlets in the floor of the big crater. I've managed to capture 5 on this one, and this reel going out to the edge here. So get out and have a look and see if you can see those little craterlets, but you have to get the sun at just the right angle. And then Ptolemaeus, that's a lovely crater, this huge one here. It's got this little ghost crater sitting in there as well. That was pointed out to me when I was younger. There's a really nice feature you can see in that. So that's Alphonsus, the crater below, and Arzechel. I'm not sure if I'm pronouncing these correctly. And Albategnius. I don't give myself any favours doing these anyway. But if you look at it from that point of view, the person pointed out to me in an image a long while ago, with these shadows, they create shapes, and the human brain is really good at picking out shapes. And somebody pointed out a photo to me when I was quite young, I was probably about 14, 15 at the time, and showed me an image of Ptolemaeus. And when the shadow's just right, it looks like a church or a cathedral. And I've only ever seen it twice since I was a teenager. So you have to catch it at the right time. And that's when I tried to capture a webcam to show it developing and do a time lapse, but it didn't turn out very well. But it did capture the effect anyway. And then next door to that, we've got this Catena Davy, or the Davy crater chain. So you can see it here. Now this is a line of craters that have been created by something breaking up before it hit the surface of the moon. So there it is. So you can see this line of craters all lined up nicely along the moon. So there's Ptolemaeus again, Alphonsus, and that's the Davy crater, and this is the chain, or the Catena, in there. And there's 23 individual craters within that impact. So you know, that's quite a nice little feature to look out for, but they are quite small craters, so you do need a really steady night to be able to see them. And here's an image taken by Apollo 12 of the chain. Look at that, absolutely marvellous, seen from lunar orbit. And another one that I really like is the Messier crater, named after Charles Messier, the famous comet hunter. And you can see why it's named after Charles Messier, because it has these 2 rays leading away from it. But it's a double crater because they think it's an impactor that hit at an angle, so it sort of bounced and made 2 craters and splashed out the material from the surface of the moon into those 2 tails. And there's an image taken a little bit higher resolution, a little bit grainy, but you can see the strange shapes of these 2 craters. But have a look and see if you can see those 2 tails, because they do stand out easily even in binoculars. So get out there and have a look at Messier crater and have a nod to the famous comet hunter from the past. And there's another one as well showing that strange structure within the crater. I mentioned Aristarchus, the really bright crater. So it's a very young crater seen in the Earthshine on the dark side of the moon. So here is the crater, and you can see it's got some sort of structure around the edges, which is quite nice. And you've also got next door to it the Schroter's Valley. So that's a cobra shaped valley here, collapsed lava tube they think. So that's great to look out for when the sunlight is in the right illumination for that. And it's surrounded by this huge brown deposit. So again, it's rich, very rich in iron that gives this brown coloration. And then an unusual feature a little bit further over is Rima Gamma. Now this is what they call a lunar swirl. Did I put it? Yes, I did put it on. So it's a lunar swirl, and these seem to be quite strange things because the surface of the moon goes dark over time because of the sunlight acting on it. But these areas of the moon, they don't fade in time. And that's also a reason why young craters look really bright, because it's revealed fresh material from beneath the surface, and that goes darker over time. But these areas, there seem to be a magnetic anomaly on the moon surface, so it actually prevents some of that sunlight hitting the surface. So these lunar swells seem to keep bright for longer than the rest of the surface. You can see it extends quite a way across the moon surface, and that's protected from the sunlight by this magnetic field that's preventing as much solar energy hitting the surface as the rest of the moon, so it stays brighter. And Fra Mauro, I did mention it's the 50th anniversary of the Apollo missions. And of course, this is the landing site of Apollo 12. They landed over here. But more importantly, because tomorrow is the 50th anniversary of the launch of Apollo 14. Oh, also Surveyor 3 landed there as well. So they wanted a pinpoint landing because Apollo 11 didn't quite land where it was meant to. So when Apollo 12 came in, they wanted to land very close to Surveyor 3 and make sure that they got pinpoint landing, so they knew exactly where they were going to land. So they nailed that one. And of course, it's 50th anniversary of the launch of Apollo 14 tomorrow, and the landing next Saturday. And this is where they landed, just above Fra Mauro crater. So launched tomorrow and then landed on the 5th of February. 5th of March, sorry. No, 5th of, it is. I'm getting confused. Yes, it is the 5th of February. Okay. And of course, another landing site of the Apollo missions, because it's the Apollo missions that probably got me into astronomy and really keen when I was young. And of course, this is part of Mare Imbrium. So this is Hadley Rille. It's a landing site of Apollo 15. So here it is in a bit of closer detail. And they actually landed just by the Rille here. So we've got some wonderful views. Have a look at the Apollo 15 images and you can see the Rille where they're standing close to it. So absolutely fantastic place to have a look and see if you can pick that Rille out. And then of course I can't finish without showing the most famous part of the moon, the Mare Tranquillitatis, which of course is the landing site of the Apollo 11 mission. And they landed just there. These are the twin craters, Sabine and Ritter, one of them still being in the shadow at this time, but it does show these lovely wrinkle ridges going across there, surrounding this ghost crater Stadius in the Mare. And if we look a little bit closer at that image, there are 3 craters on there named after the astronauts. There's Armstrong, and that's 4.6 kilometers wide, so it gives you some sort of a sense of scale on the image. Collins in the middle there is only 2.4 kilometers wide, and then Aldrin is a bit bigger at 3.4 kilometers wide. So Collins has missed out again. He missed out on the landing, and he seems to get missed out when people talk about the Apollo 11 landing as well. But he was just as important as the other 2 that actually did walk on the moon. So that's my sights of the moon. So I hope you've enjoyed my tour of the moon. And of course, I'm going to be on social media putting things about the Apollo missions and as they go on the 50th anniversary. Thank you very much.
Thanks, Dave. Tell us about your next meeting of the Virtual Astronomy Club.
Yes, we've got Nicholas Booth, who's coming in to tell us about Hope and Perseverance, Dispatches from a Red Planet.
Oh, that's great. Yeah.
So that's on Tuesday evening at 7 p.m.
And you can tell us the place to go to?
Yeah, if I pop it in the chat to everybody, let me just move this over here. So the web, I'll make sure it goes to everybody.
Did you take all those lunar photographs yourself? I guess you did.
Yeah. Beautiful
photographs. And I can see the colours that you were talking about on many of those as well.
That's right, yeah, because when I use a one-shot colour camera, so what I do, I go in and I slightly saturate the colours. But it's a very fine balance between bringing out the colours and making them too much.
Yeah, so
yeah.
So I hope it encourages a lot of other people to go out and photograph the moon. And I hope one day we'll be able to get our lunar section director, Dave Graham, on. I'm not sure if he's watching today, but he will. He's got to get his a Zoom talk together, and maybe he'll be coming along to a meeting in a few months' time. So that's great. the moon is a great object to watch. Don't overlook it just because it's wiping out the deep sky objects, as Dave observes both types. So he's certainly made the most of the bright parts of the moon, and all phases of the moon are equally interesting. I love those pictures, particularly with the Mare Orientale, when you see the edge, the limb of the moon, and you can almost imagine yourself at high magnification flying off across the surface of the moon. Of course, it's interesting to compare your photographs, for example, and your views of the limb of the moon and the fairly shallow slopes of the craters with the views which people drew way back in even the middle of the last century, where they showed, as you say, everything had to have really sharp spikes, and there are plenty of drawings. Even people like Chesley Bonestall drew very sharp spikes on the lunar mountains, whereas in fact you don't need to assume that they're quite shallow slopes in fact, aren't they?
But when the sun is rising over those features, they do cast really long shadows, and it does make them really stand and pop out along the terminator. So it's well worth looking up and down the terminator and seeing what you can see. You can see light flooding into little craters. You can see a bit like the eyes of Clavius. You can see other little craters popping up above the shadows and things like that. So there's always something to look out for.
Yes.
It always looks different. So every time you go out there, the sunlight angle is slightly different, and it looks different.
Yes, and Paul Addison on chat has just said Surface of the Moon in the film 2001 also had those very spiky lunar features, but that's Hollywood for you. And actually, I always say that is one of the most obvious reasons why the Apollo landings, really, the photographs they took were genuine ones. If Hollywood had faked those, they would have made a much better job of the lunar landscape, wouldn't they?
Yeah.
Because that's what we would have all expected to see. So the very boring pictures we saw had to be real. Hollywood wouldn't have made it up like that. Well, that's great. Thank you very much, Dave, and hopefully that will inspire people to go and look at the moon. I'm glad to say that we've got meetings coming up in April and July. We've got the speakers all organised for those, and we will try and add the odd meeting in between for you if you're interested in coming along. We will. We certainly trying to add some more meetings as well. And don't forget Vicky shows every Friday night. The last one was an absolute cracker, full of information, and also contributions from individual members as well, which is great to hear. Stephen, over to you.
I guess it just falls to me to wrap up. I was just going to add that Vicky's meetings are really buzzy. They're a great show. So catch them on Friday nights from 8 p.m. I think it is.
Yeah, that's right. Yeah.
Yes.
Mostly every Friday night.
Facebook.
And the next one will be David Hardy, and also Stuart Clark will be on, and also the news from Elena Tsiakalaris, who will be giving the latest news, which hasn't happened yet. We haven't heard about it, and she will be giving the latest space travel and weather, as Vicky calls it.
Well, tune into that. It's going to be great. So thank you very much, everybody, for attending. I hope you found it as interesting as I did. It was a great meeting, I thought, anyway. And the Hubble constant controversy is the weirdest and probably the deepest and most exciting mystery in cosmology at the moment. And it was lovely to see so much going on and to find out what you can see and do observing the moon as well. And I just love observing the moon. It's like seeing another world. I mean, literally, it's seeing another world. It's just glorious. So thank you very much, everybody. And the last thing is just to say the next meeting will be chaired by our new president, Andrew Coates, who's a professor at MSSL and UCL. Is it MSSL or UCL, would you say you're at? Andrew.
You're muted.
Oh, you're
Andrew.
on mute.
Yeah. So we're part of UCL. We're a department of UCL, Department of Space and Climate Physics. But Mullard Space Science Lab, yes, has a special identity of its own as well. So yeah.
I'd like to say thank you to Stephen for putting up with us for the last 2 years, and I'm glad to say we're not seeing the back of him yet, because he will be around as vice president, and quite often in the habit of people that we invite to become SPA presidents, they stay with us for quite a while after that. So we hope to see him many times again in the future.
It's been my pleasure.
Thank you very much. And with that, I shall close the meeting, and I hope you've all enjoyed it. Goodbye, everybody. Bye.
Take care.
Bye.
Bye.